Heterocyclic compounds, and we said we're going to be talking about the meaning of heterocyclic compounds. All right, and then when we talk about cyclic compounds, you know there are compounds that have a kind of ring shape. It mustn't be in a circular form though. Just can be hexagon, can be hexagonal, it can be pentagonal, or any shape that is enclosed like that. Okay. And then when we talk about cyclic compounds, we can talk about two types. You can say homocyclic and then heterocyclic. And who can tell me a very, very good example of homocyclic compound? We have benzene. Homocyclic, benzene is a carbocyclic compound. When we say carbocyclic, we're talking about compounds that has only carbon atoms in the ring. Like, you know, carbon is basically should be basically the most common example because carbon undergoes catenation, right? Okay, so you can see that benzene is a very good example of homocyclic. It has the same kind of atom in the ring that makes up the ring. Okay, it doesn't mean there are no other rings, atoms attached to it, but basically what forms the ring is mainly carbon. But when we talk about something like when we talk about compound like this, what will you say about this compound? What will you say about this compound? Okay, what will you say about this compound? What will you say? Will you call this homocyclic? Homocyclic meaning the same atoms make up the ring. Or what will you call it? In this case, we call it heterocyclic. Heterocyclic is basically uh, compounds with rings containing at least one heteroatom. When we say containing at least one hetero, whenever you hear the word homo, it's telling you about same type. Hetero, different type. So basically, you can see that this is the skeletal form of pyridine. So we know that these are carbon atoms. But when we go to this point, we discover that this is what? A nitrogen atom. So this obviously is an example of a heterocyclic compound. Heterocyclic compounds are organic compounds with ring containing at least one heteroatom. And the most common type of heterocyclic compounds we see are those containing heteroatoms like nitrogen. You can see those containing oxygen. You can also see those containing sulfur. Okay? For that of nitrogen, we have given an example, pyridine. Okay? And then for that of oxygen, we have ethylene oxide, or you can call it oxyrane. Oxyrane is also a very, very good example of what? A heterocyclic compound containing oxygen. And then when it comes to sulfur, examples, we have thiophene. Thiophene is a heterocyclic compound with what? Sulfur as the heteroatom. So in heterocyclic compounds, it is not just made up of carbon. The carbon don't just make up the ring. You can have at least one heteroatom present. Okay, so at least meaning you can even have more than one heteroatom present in the what? Ring, cyclic ring. An example is pyrimidine. Pyrimidine has two nitrogen atoms in the ring. It's just like pyridine with one more nitrogen atom attached to the what? Third position. Okay, pyridazine attached to the second position, one more nitrogen atom attached to the second position here. Then you have pyrazine and you have pyrazine attached here. Okay, that's just the difference. But in that case, you don't just have one heteroatom, you have more than one. Okay, thank you.